right, we are live. A warm welcome to our session. This session will be hosted by me and Peter. So glad that you could make it to our session. The session is basically about cognitive search and using specifically custom skills. And then we will demonstrate how you can use Form Recognizer as a custom skill in your entire skill set or skill chain. So first, let me introduce myself and Peter. My name is Bernd. I'm located in Linz, Upper Austria. I'm an IT solution architect at Andritz Group. And yeah, I'm curious about all cloud stuff we have out there, and this is a cool use case we wanted to share with you. Peter, would you like to introduce yourself?
Yeah, hello from my side. My name is Peter. I'm working at work as an enterprise architect. Was former working at Microsoft as an enterprise architect, Microsoft Services. And since 3 years, I'm basically concentrating on things like governance, but my real intention is to understand cognitive skills and AI, and this is the point what we are talking about today.
All right, so let us show you what we have prepared. So we will start with describing the business case. So what was our motivation to dig into this topic? How does the overall solution look like? As said, we will try to demonstrate how you can easily train a custom form recognizer model and then use it as a custom skill. So the whole thing we will demonstrate in the demo, and we also want to share some lessons learned with you in case you wanna you get some interest or have similar use case that you are not going the same pitfalls we had. All right. What we do not cover in this session is how to deal with cognitive search generally, like how to create a data source, how to connect data, how to create an index, and also configuring the indexer. So we heavily recommend to replay Tony's poll sessions about Microsoft Search. I guess he covered all of that stuff. And what we also do not cover is how to really create, implement, and deploy an Azure function. So we will wrap something into an Azure function. We will show you, but we will not be able to demonstrate the whole process. All right. So starting with the business case, what's the case? What's the target? So basically, we want to index, extract, and also build enterprise context with certain kinds of information. So like in Andritz, we have quite old historic project documentation, which is mainly documented in Word or PDF. And there is quite some knowledge in. We want to extract this knowledge. We want to reuse it in multiple ways, but we also want to create kind of context to other entities we have in our organization, right? Also, we have this documentation in different languages. And by saying I want to reuse it, of course, we also want to translate it automatically to provide this knowledge to a broader audience than, for instance, only German users or engineers. So that's the first piece. So we want to extract, get the knowledge and reuse it. And the second piece, as I said, is we want to build kind of an information graph in the organization. And an organization usually, has different patterns, but also usually main entities like customer records, project records. A project has usually a project number, which is kind of unique. And with this documentation, we built a use case on. We will be able to do so by using the form recognizer. That's what we learned, because this documentation has a very equal layout, a very equal visual layout, which only varies over the years very slightly. So we will, with Form Recognizer, we can use this kind of stable layout and pick certain information as key value pair out and later reuse it in this whole context building process. For this, of course, it's actually required or recommended that you have, or can you refer to key entities in your organization, as I said, projects, customers in your same system, or maybe other training sets you already have by using other services. So again, to summarize the business cases, extract information within the search and index use case, but also build graph information, graph context to other existing entities you have in your organization. What we did is basically we followed the default schema you have when you do enterprise search and indexing. So from data source over document cracking, maybe these days you can plug in certain cognitive skills in this chain. In the end, you have then kind of enriched documents. And these documents you want to project to a kind of store of other entities. So this is a default schema you see on the top. And in our use case, translated, this schema basically means we index the document types we have. We put focus on certain specific document types like project technical reports. We crack it, we index, we apply cognitive skills, but also apply custom skills to end up in a kind of enriched graph model, which usually has in enterprises, I would say, typical entities, customers, maybe install base, project, and other things. Peter, would you like to add something here?
I just want to add the difference to the normal approach in indexing is that we just crack the document, as you see in this pipeline on the top. So we get the document, we're cracking it, and then we are using a lot of predefined skills from Microsoft, like translation skills, like keyword skills, but they are not very specific for our company. So they are trained for the whole world. And this is the point where we found out that we could add a lot of additional value if we train the documents we know, or the information we are using. We are using the information we know as a training set. So this is the big difference, that we are building up a training set which is really specific for Andritz. And this is where the additional information comes out, because Microsoft does not know anything about the type of documents that Andritz is using. So they can crack it, they can interpret it, they can extract some basic information. That's quite fine, but it's not very useful for the end user. What's useful for the end user is the Andritz-specific knowledge, which is, for example, as Bernd said before, the project number, the customer. But for that, you have to know about where this information can be found in the document and what type of document we have here. So this is the big addition we do, additional to the standard AI skills that we get out of the standard Microsoft Cognitive Search.
Okay, thanks. Let's move on with the actual solution. So what you can expect now, so we will just have 2-3 slides to explain the overall solution and the set of solution we have, the main components. And then we will go, I think, straightforward into the demo to show all the pieces. And later, after the demo, we will come back to the slide deck, okay? So referring back to the schema we just had a look at, for the final solution we're using now, we have 3 major components we're using. Of course, as a baseline, we're using the cognitive search and its built-in capabilities and also built-in cognitive services to, as Peter said, to get this additional trained model for Andritz. We're using Azure Form Recognizer to train this model, and there, in a, I would say, rather easy way by using the studio to get to train model and then just refer back to that model. And to bridge the two things, we're using an Azure function, which is basically connecting or wrapping the Azure Forms Recognizer API towards the cognitive search as a custom skill. As you can see in the Azure function part, we can also retrieve, for instance, information from Confluence wiki pages with the same setup. This is nothing we cover in this session. So in this session, we focus on how to use, how to apply Form Recognizer on a specific set of documents to get out the data there. So I will show later in the demo, but this is what you could expect from Form Recognizer. It's basically like, I would say, all Azure services in that area, a rather easy and easy accessible learning service, so to speak. So Microsoft really enables you there to have access to a lot of services, which enables you to build easy, without high effort models you can use for that whole data processing process. What we did is, as a preview for the demo, we know that we have a certain set of documents which share, I would say, to 90% the same visual layout. And the Form Recognizer is something which enables you to use that layout to define labels and key value pairs, more or less. And it helps you to train that model, which you later on speak to. Our example was, as I said, technical reports, which have been created over, I don't know, 20 years, mostly in Word and PDF. They share, as you see, the same header as a kind of info sheet. And we know that in an area over here, it's the document type. In the other area, it's the issuing date, and here the issuer. And this is where Form Recognizer can take advantage of. You have kind of stable areas on your document. You just label, then you put some stuff in, some documents to train a model, and then you have a kind of ready-made model you just use later on in EasyChain. So the message there will be easy access, fast modeling capabilities, easy use in the post-processing steps. Peter, would you like to go through the whole process?
After we trained our documents, which is done with the Form Recognizer, we have to connect it with the skill set pipeline. So as hopefully you have been in the session from Tony in the morning, but just to explain a little bit what the skill set is. The skill set takes the information which is brought from the document and walk through different steps, the so-named skills, to extract out of this lot of text specific metadata. For example, the language, the keywords, the author, and in our case, we are using this web API skill, which is a custom skill. And this is a very, very powerful skill, because with that you can connect it with any type of matching algorithm. And this is what we are doing here. We cannot use the web skill directly to call the Forms Recognizer, so we have to put the very small Azure function between the two pieces. And this Azure function is more or less the bridge to the Forms Recognizer and converts the input from the skill. So this is the name of the document and the key how to access the document. And the function, the Azure function itself passes this over to the Forms Recognizer, and the Forms Recognizer returns the extracted metadata, and the Azure function translates this back to the web API skill, to the custom skill that it's the skill can put it into the skill set. After that, we can put the data which is returned from the Forms Recognizer into the index fields. So we have specific index fields for the type of documents, which is the doc creator and the doc type and the project number and so on. So all the things we are getting from the Forms Recognizer we can find not only in the full text index, but also very specified in the metadata field. So everybody who was working with SharePoint in the past knows that metadata is a very powerful method to qualify information, but unfortunately, it's a very it's a process which needs to be done manually, and this is what we are doing here is automating this extraction of the metadata which is already in the document and put it into the specific index field in the Azure Search Index. The final thing is, and this is what Bernd said at the beginning, indexes can be one target of the information. So if we are using it for searching, for qualified searching, for example, I will show that I can definitely search for the doc creator, which is hidden in the document. But we can also use it to build up this so-called knowledge graph. So if we put together all the information which we get back from the Forms Recognizer over a lot of a big set of documents, then we can build up an information and match this with a pre-built, let's call it metadata tree, where we can navigate, for example, through the type of documents, to the locations where the projects have been, to the name of the project, and we are going directly into this knowledge graph. So we can use it as a graph information for the whole company.
Thank you. So this will be the point where we jump right into demo. I would share with you how to create a Form Recognizer project, a custom model. What are the major steps you have to go? Ending up in seeing what's the output, the return, if you just send one document in there as a reference. Okay. So let me just share that. So if you work with Form Recognizer and you want to start training your model by uploading samples, document samples, you basically need two things. You need the Form Recognizer instance, which you just create as any other Azure resource, like a web app. So that's pretty straightforward. But also you need to refer to a blob storage, because if you use the studio, the sample data which you do the training on has to be stored in a blob storage. So this is basically the two preconditions you need apart from the data. So you see that Form Recognizer also has already built-in models for certain use cases, like scanning invoices, which also have typical pieces on it and information types, business cards, and so on. What we did is we basically created a custom model, and doing so, you basically first need to give it a name. You need to let's do it in this. So you will give it a name. You would refer already to a blob storage or an instance of the Form Recognizer in this. So just this one, and also here an important information is the API is improved over time. So usually there is what we learned is there's usually 2 API versions available or active, and later on, if you also use that API with an SDK like Python or .NET or JavaScript, this needs to match. So be aware what API you use, because later on you have to use the correlating SDK version. In this case, I'm creating API version 2021 because this is rather new from this year, so no chance to look at it. And then as a second step, you are referring to a source. So where is my data uploaded? which is a blob storage, which needs to have at least a container, and then you're good to go, so to speak. So Form Recognizer is preparing the environment for you. In this case, you see that I've prepared this already. So Form Recognizer will show you the sample documents, the sample data you have in. And in there, you could start basically defining fields. There is also different methods how you want to train the model in Form Recognizer. But in our use case, as we know that the visual layout is pretty stable over 10, 20 years, it's rather easy to say, a Form Recognizer, this will be this area, we will always have the title, the doc title. And I want you to capture this as a field of type string, which is default, right? So, and this exercise you basically do several times. So that's kind of manual work. And then you ask Form Recognizer to train the model, which is a built-in mechanism. And once, well, so let me go back now to, yeah. So once the building process of the model is done, you have to give it a name or a model ID. And this is important because this is where later on in the SDK or REST API you will refer to. So Form Recognizer captures, so to speak, that the model also in the same blob storage where you got the data from. And after labeling and training the model, you will get a model ID, which is your main reference later on. So again, I'm showing the main steps. So you open a project, you put your training data into a blob storage. The Form Recognizer is automatically fetching and analyzing those documents which you have in that blob storage. And then you would start defining areas, fields in your documents. If you say like this is stable over time, you can also define tables. What we learned is that the fields which refer to an area and the string, that's pretty straightforward. It's able to recognize date. So this is really a cool foundation and a pretty good foundation to build your own data sets. So once you have a model, or you have an environment, you have a model trained, you can actually already refer and use this model with REST API. Form Recognizer also has, apart from the SDKs for the main languages, a REST API. So I can show you what that is looking like. And to prove, so to speak, that once you have a trained model, it's rather easy to automate tasks by speaking with REST API to that model. So I missed out to open Postman before, but it shouldn't take too long. So as you can see, just this little collection here in Postman, this is the Form Recognizer API. It's not yet the API we wrapped in Azure Function to speak to cognitive search, so to speak. It's the Form Recognizer API. And you see that you would go 2 steps, more or less. So first, you would send a new document which you have now in your queue to Form Recognizer. How would you do that? In this case, we gave a reference to a blob document with having a shared access signature. This is something maybe Peter can show later on. This is automatically done later on in the whole skill chain. So the source here is a document, a new document we want to analyze. We put it somewhere into blob and created now a shared access signature that Form Recognizer would be able to fetch and analyze. So you see that's basically the only post item you need to state. So the post body is rather rather less. And then you would just send it for analyzing. And you see in the response code that Form Recognizer has received it properly. There was no error to access, and it's now in analyzing queue. This is basically what the accepted, the 202 says. And later on, you can actually get the results by having a GET request. You see that you basically always refer to a model and an API version. That's the important thing. So do not mix up API versions of Form Recognizer, SDK, and REST API. This will sometimes not work, especially when there is breaking changes between one API version to another one, right? So, and what you can see is there that the document has been analyzed, and this is the response payload of the document. There is multiple nodes in, but you see the content itself. You see what model you have been referring to. And the interesting thing is that if you look for the fields node, it was able, so to speak, to recognize the fields we have defined in the model before with this new document. So the field document number was recognized, and the value is ABC/22 whatever. So this is usually a unique identifier in your organization. Also, it got document summary and so on and so on. So this is, we have here the creation date as well. So this is basically it returning you all fields you have trained in the model back in the payload. And to make it now available to the cognitive search, we would basically wrap this in an Azure function, pick out selected recognized fields we want to have, and make it expose it as a return payload to the cognitive search. As I said, there is all major languages which Microsoft typically supports available, also for Form Recognizer SDK. So you can do Python, .NET, Java, JavaScript, or Node. I can show you quickly how this Azure function would look like. So it's actually not really a big deal for demonstration purposes. It's rather, I would say, maybe this one is not production ready, but it's good to show. So in this case, it's TypeScript. So you have the packages and the types. In here, you would import from AI Form Recognizer. And if you have already used previous versions of the API, you want to switch to the new version, you will see that the functions and the operators and so on, the types have slightly changed. There is a mapping table in the documentation of Microsoft. So if you need to upgrade from one version to another one, I would refer you to the mapping table to really get from one state to the other. So what we will need is then the Form Recognizer endpoint, key, and so on. And then we basically just create a Form Recognizer client with the begin analyze documents operation, and we just pass over the model ID, the URL of the document, and then we wait until the analyzation is done. We get the payload, limit the payload a bit, select single pieces, and return it back. So this is basically all we did to make it available for the Azure function.
Information we need for the pipeline afterwards.
Right. So this is the foundation we need afterwards. So as Peter said, you cannot really connect Form Recognizer API directly with cognitive search. So, and maybe you're not interested in all fields you have defined. So it does make sense to reduce the payload, maybe make it more performant than in this code, but it does make sense. So this basically was the major steps you have to go with Form Recognizer: data, analyzing, labeling, training, and wrap it into a function. And this would be another foundation to reuse that in the cognitive search and index a skill chain. And I think with this, I can hand over to Peter.
Okay. Can you show, please? Yeah, thank you. Thank you. What we see here is I'm using Visual Studio Code with the Azure add-in, with the Azure extension to connect to the cognitive search. So we can do this in the web API, in the web UI as well, but I'm preferring Visual Studio Code here. And if you open up the part with the in the cognitive search, you see that we have different sections. We have the index section, we have the data source section, we have the indexer section, and we have the skill set section. And first, we want to have a look on the index section, because here we have different indexes. Our index is the kit files index 2, where if we have a look on the index definition, which defines the fields that we have in the index, we have like content, we have metadata, storage size. These are all the information we get directly from the document cracker. But if we go down to the end of the index, we find some very interesting part. Here we find the doc code name, doc title, doc creator, and doc summary. And these are the 4 fields we want to fill up via the forms recognition process. So what we have to do is to connect these fields, to fill up these fields with this custom skill. So we go down to the skill sets and have a look on the kit file skill set. And here we have a lot of, you see it's very, very long. So we have a lot of built-in skills, like the built-in entity recognition skill, which brings out the categories like organization, persons. But all these skills are trained with a non-specific data. It's trained with a lot of data from Microsoft, but it's not specific to Android. And this is why we found out the information there is interesting, but it's not very useful or it's not very specific for the end user. So if we go down a little bit and scroll to the skill set, to our web API skill, which is the skill we are using to call the Azure function. So you see we have the web API. We are using the web API skill to call the Azure function, and from the Azure function we get the document code and document title, document summary, and document creator returned, and we put it into the correct index fields I showed you before. So this is the only thing we are doing in this little skill. We just have to take a look on some things where this is the URL for the Azure functions. So as I mentioned before, we are not calling directly the forms recognizer. We are calling the Azure function, which is HTTP post. And with this Azure function, we supply the Azure function with the URL of the document. So this is brought to us from the document cracker of the cognitive search via the metadata storage path field. And as Bernd showed before, we need the SAS token to access it in a safe manner. So this we also get from the document cracker. So it's not static connected, it's dynamically connected based on the data we get from the document cracker. From the output side, we see that we get back the document code name, document title. These are the fields that we defined in the Azure function that they should be returned, and we only have to tell the skill set how we want to name it for the index. So this is the connection between the return values from the Azure function to the index. So after that, after we started the indexer is is the machine or the definition which connects all the different things. So if we have a look on the indexer, we see that we have we have our skill set defined here. We have our target index defined here. We have the data source. This is where the indexer iterates through. And down here we have the field mapping between the fields we get from the skill set and the mapping to the correct to the correct target field in the index. So the indexer is connecting the things we get out of the skill set to put it onto the right place in the index. So after we have run this, we can do this directly from here. We can run indexer. I will not do this because this takes about, for our small test set, about 10 minutes. So we do not have that time. But I already did it in the before the session. And if we take a look on the results of the document, so these are the documents that are in the index. And if we have a look on the document, we can see that in the index, the skill set populated all the different index fields, for example, organizations. But you see, in my I do not know so much about Andritz in detail, but the only organization which seems to me really relevant in this document is Andritz Hydro and all the other synonyms are not really relevant for the document. But it's important. We see that down here. Here are the outputs from the document from the Azure function, or more in detail from the forms recognizer. So you see that the documents, the content which was on the page was qualified with the forms recognizer. It was translated via the Azure function into the correct format that the skill set understands it, and the skill set puts it into the correct index field. So now we can directly search, for example, for doc creator equals Bernd Schickerbauer, which is not in the metadata of the document, but it's really extracted out of the document and put into the metadata of the index. So this is more or less the whole story, and I would hand over back to Bernd, that he shows our lessons learned.
Thank you, Peter. So the main message is basically that naturally certain patterns like project naming or project records like project code, project name, whatever, this is different patterns are different across all organizations, right? So built-in skills actually cannot really recognize out of the box all those entities which are enterprise specific. So this is why for these major enterprise entities, which are not always equal, only this can only be covered with custom AI training data, like we do with Form Recognizer. So this was our main message or learning, that whenever it comes to enterprise or typical enterprise entities, you may need to find your own way to get these entities recognized, so to speak. At the same time, the web API skill is obviously key for so many things, and basically for creating an enterprise context, because it enables you to connect to so many different data sources, which also I guess you naturally have, because usually you have a very wide application landscape, and web API skill basically lets you indirectly connect there to find and look up relevant other major entities in your organization. Something which I would assume refers to all learning and artificial intelligence services in Azure Cloud is that the access and the usage also for Form Recognizer is really straightforward. So you do not need to be ultimately an AI expert or data scientist. So access is rather straightforward. As I mentioned before, the API changes, sometimes minor changes, sometimes major changes. So please take care that the API version you're training your model with refers to the corresponding SDK you may be later using. And so in this case, we did 2021 API version, and at the time, the SDK was in preview build. So you need to find the matching thing, but this is actually good documented on docs.microsoft.com. The next one for you, Peter.
Yeah, the debug sessions. Debug sessions are great because I wasn't aware that this exists in the cognitive search. But the problem is that if you saw most of the code in the skill set is just a JSON definition, and you start the indexer, and the indexer is doing what you define in the JSON definition. And if something goes wrong inside of that because you have a wrong URL where you make the call to, or something like that, or you get the wrong format back from the forms recognizer, you do not have a chance to see what's happening inside of the indexer. And the debug session is really a very, very good session that you, after the indexer ran and he's thrown an error or a warning, that you go into that warning and you can repeat the call to the document of the skill set in the skill set. So you can do something like a single step in the skill set to see what is sent via the skill set to the Azure function and what is returned from the Azure function. So you can really debug the skill set with the debug sessions, and I really recommend have a look on it. It saved me so much time to see what went wrong in the skill set. And also, what you saw here is I used the add-in cognitive search, or to be more in detail, it's the add-in, the Azure add-in, but the section cognitive search to manage all the index skills and indexes, because the web UI is fine, but it has some limitations. And if you do not use the web UI, you have to use it all with Postman, because Postman with a HTTP post, you can do everything with the index definition. So using the VS Code add-in makes it really much easier, because it capsulates into the calls into HTTP calls, but you do not have to use Postman, and you know exactly the format of the payload. So this is done by the add-in itself.
Thank you, Peter. So with this, I think we are through. I hope we could share some interesting insights for you as well. So maybe you got curious in using Form Recognizer or cognitive search in general. Thanks, Peter, for your support all the time. So it's cool to work in this pair. So see you in one of the next sessions. Bye-bye.
Bye-bye.